They say our sun is just an average star, but what if I told you it's hiding mysteries more incredible than we ever imagined? NASA's groundbreaking discoveries have shown us a side of the sun that's both terrifying and mesmerizing. We're talking about solar storms powerful enough to disrupt all life on Earth, magnetic fields that dance unpredictably, and temperatures hotter than anything we thought possible. Ready to find out what NASA uncovered? Our sun isn't just a glowing ball of gas in the sky. It's a raging powerhouse, a dynamic sphere of plasma that shapes life on Earth and holds secrets that we're only just beginning to unlock. Since 2010, NASA's Solar Dynamics Observatory, or SDO, has been beaming back incredible images and data that let us see the sun in ways no one could have imagined. Today we're diving deep into these discoveries and answering a question that scientists have been puzzling over: just what is our sun capable of? But studying the sun is no easy task. How do you observe something that can incinerate spacecraft and blind our instruments? How do you see through blinding light and record temperatures that make even metal vaporize? NASA faced this challenge head-on, developing advanced technology to go closer to the sun than ever before. Through this, they revealed an unpredictable, sometimes terrifying reality: the sun is not the calm, warm star we see every morning. Instead, it's a volatile force that could affect us in ways most people don't even realize. Let's start with NASA's Solar Dynamics Observatory and its mission to study the sun in extreme detail. Launched on February 11, 2010, the SDO is in a geostationary orbit around Earth, where it constantly watches the sun. Imagine this: every 75 seconds, SDO captures a new image of our star in different wavelengths, each revealing a unique layer of the sun's atmosphere. In just over a decade, it's captured more than 425 million high-resolution images, each one helping scientists piece together a clearer picture of our sun. One of the biggest mysteries SDO aims to solve is what drives the sun's magnetic field. The sun's surface is a complex dance of charged particles that create magnetic fields. These fields twist, collide, and snap back in sudden bursts, creating what we know as solar flares and coronal mass ejections. But why does this happen, and what are the consequences? To understand the chaos, let's talk about solar storms. You may have heard of solar flares, bright flashes that erupt from the sun's surface. These flares are triggered when magnetic fields near the surface get tangled up, creating an explosive release of energy. And they're more than just light shows. When a powerful enough flare is pointed at Earth, it can cause serious disruptions. From GPS systems to power grids, the technology we rely on could be affected by these outbursts. But flares aren't even the biggest concern. There are also massive eruptions called coronal mass ejections, or CMEs. Imagine the sun throwing out billions of tons of plasma into space at millions of miles per hour. These eruptions can travel across the solar system, and if they hit Earth, could trigger geomagnetic storms. The most intense storms can create brilliant auroras at lower latitudes, but they can also disrupt satellites, cause power outages, and in extreme cases damage our infrastructure in ways that could take months or even years to repair. SDO has recorded countless flares and CMEs over the years, including some of the most powerful in recorded history. These discoveries helped us understand that the sun's influence extends far beyond light and warmth. It's a direct threat to our technology and potentially our way of life. Another fascinating discovery is the sun's corona, its outermost layer, which is much hotter than its surface. This layer can reach temperatures of up to a few million degrees Celsius, whereas the sun's surface is about 5,500 degrees Celsius. For decades, scientists have asked why the corona is so much hotter than the layers beneath it. It's a bit like standing near a campfire where the air around it is hotter than the flames. Doesn't make sense, right? SDO has provided data that hints at an answer. The corona's extreme temperature may result from magnetic waves that transfer energy from the sun's interior to its outer atmosphere. Another theory is that nanoflares, tiny, almost invisible flares happening all over the sun's surface, combine to heat the corona. But these theories are still being tested. Thanks to SDO, though, we're closer than ever to solving this mystery. The sun also has a predictable pattern of activity called the solar cycle, which lasts about 11 years. During a solar maximum, the sun is covered in sunspots and experiences intense solar flares and CMEs. During a solar minimum, it's quieter. SDO has been observing this cycle closely, recording changes in the sun's behavior over time. Every cycle, scientists observe a buildup of energy, followed by explosive releases as the sun's magnetic fields reset. Each cycle brings new data and insights into how these shifts could affect us here on Earth. And with every solar maximum, we hold our breath, wondering if this will be the cycle when a massive CME hits Earth, testing our preparedness in ways we might not be ready for. SDO also plays a crucial role in studying the solar wind, the constant stream of charged particles that flows from the sun and moves throughout the solar system. This wind shapes the bubble around our solar system, known as the heliosphere, which protects planets from cosmic rays and other dangerous particles. When the sun's magnetic activity intensifies, so does the solar wind, which can create more extreme space weather. Space weather affects not only Earth but also other planets, satellites, and spacecraft. By understanding the solar wind's patterns and how it interacts with our planet's magnetic field, we can better prepare for events that could disrupt our technology and even pose risks to astronauts in space. Despite the breakthroughs, observing the sun is full of challenges. SDO operates continuously in a high radiation environment, which takes a toll on its instruments. Occasionally, the Earth and Moon can eclipse the SDO's view of the sun, causing data interruptions. And in 2016, a significant problem with its atmospheric imaging assembly, or AIR, threatened to compromise one of its primary data streams. Engineers had to apply creative solutions, including advanced image processing, to continue collecting high-quality images. While SDO has been instrumental in revealing much about the sun, it isn't alone in its mission. NASA's Parker Solar Probe, launched in 2018, is getting even closer to the sun. It's set to dive through the corona, collecting data that could finally solve some of our biggest mysteries. The Solar Orbiter, launched by the European Space Agency and NASA in 2020, is taking things further by observing the sun's poles, a region previously unseen by any spacecraft. Together, these missions are painting a more complete picture of the sun, helping us understand its internal workings and giving us tools to predict and prepare for solar activity. The more we learn about the sun, the clearer it becomes that its activity isn't something we can ignore. In 1859, a massive solar storm known as the Carrington Event sent charged particles crashing into Earth's magnetic field, causing fires and telegraph outages. If a storm of this magnitude hit us today, it could have devastating effects on our infrastructure, from disabling satellites to knocking out power grids worldwide. What NASA has discovered is that events like this aren't just a possibility, they're part of the sun's natural cycle. By studying the sun, we're preparing ourselves for the next Carrington event, learning what needs to be done to protect our technology and prevent a global catastrophe. NASA's Solar Dynamics Observatory has given us a closer look at our sun than ever before, revealing its power, complexity, and volatility. With each image and burst of data, we understand a little more about the force that keeps life on Earth thriving and the risks that come with it. From breathtaking solar flares to the invisible winds that shape our magnetic field, the sun is far more than just a bright star in our sky. It's an essential part of our cosmic neighborhood, influencing everything from our climate to the future of space exploration. As we venture further into space, understanding the sun will be critical, and thanks to the SDO, the Parker Solar Probe, and the Solar Orbiter, and we're on our way to doing just that. Hit subscribe and stay tuned to explore more mysteries of the universe with us.